Hello, this is Alex. Today we're going to be going over lab number 7 for chemistry 2. It is going to involve ferrofluid and magnets. So what we're going to be doing today is first I'm going to go over what we have. We have ink toner, black ink toner, vegetable oil, and magnet, an rare earth magnet. So let me go over what we're going to be doing. So first I'm going to put in about 50 mLs of ink, black ink. I'm going to add 2 tablespoons of olive oil, and that's going to mix up and create a fluid. You're going to have the base with the olive oil, which is going to have magnets, small nanoparticle magnets, and then after they're mixed up, I'm going to put this magnet to it, and the ferrofluid, which is in the oil, will hopefully magnetize and react, and you'll see these spikes form, this glimmering spikes from the ink. It will help visualize it. Personally, I've done this a couple times and I have not been able to. I've tried different magnets. I have just been unsuccessful, but hopefully this time for this video, we will be successful. All right, so let's get started. And I'm going to go over much more detail as we go through the video. Okay, so I'm going to put about 50 mLs of black toner ink. Okay, so we got to the 50 ml mark here. Okay, and then now we're going to do 2 tablespoons of oil. And the oil is the ferrofluid here. It's not that the oil is metal, but there are particles, iron, nickel, cobalt. These are 3 large atoms that, the 3 majority of atoms that usually magnetize. And so they're in there, they're in space. It's called a colloidal solution. And what that means is there's these nanoparticles that are in there, they're insoluble. And when we put them in there, we're gonna mix this together with the ink. And they're it's called a ferrofluid. So they're not magnetically charged now, but when we get this external magnet and use it, it will magnetize them then, creating the spikes where you have these lines of where the magnetism occurs, and then you're going to have these spikes in the fluid. All right, I'm going to get 2 tablespoons. Okay. Of course, oil is oily and it's going to sort of clump up together in the beginning. But one thing oil does have, it has like a surfactant, so all the nanoparticles in the oil are not clumping together. And I'm a nurse, so we use, I mean, the human body, when I work, sometimes the doctors will go over it, but surfactant is something we have in our body, we have in our lungs. It keeps our alveoli, so when we breathe, when we expire, our lungs expire and release CO2, our lungs, our alveoli do not collapse because we have something called surfactant, which keeps our lungs from collapsing. It keeps the surface from sticking together. So that is in here too, so I'm able to make that connection. And here it keeps the surfactant in the oil, keeps the nanoparticles from clumping up together. So when you do see the spikes, hopefully when this happens, we will see these spikes that are sort of uniform and equally distributed and not clumped up together. Okay, got the 2 tablespoons of oil. Going to mix them together. Okay. So what we have here, as you see, this looks quite thin. It's just the oil and the ink toner. Okay, this is quite a thick jar, so I'm just going to pour it in the plate, and then we can use the magnet. So we'll review at the moment. We got ink toner and we have oil. The oil is the ferrofluid. It has these tiny nanoparticles, metals. Three large examples: cobalt, iron, and nickel. These three are some of the few atoms that can be magnetized. So we're gonna have this magnet, and when we get it close, hopefully it will create a magnetic field, and they will create spikes due to the alignment of the magneticism, and we will be able to manipulate the ferrofluid with the magnet. Okay, I'm gonna pour it on the plate here. It's quite a lot. Okay, we have the magnet, and hopefully this magnet will be strong enough to create a magnetic field, magnetizing the ferrofluid, and our lab will be done. Okay, not seeing anything react right now. Nothing, got to have it very close. Nothing, gonna try to go under the bottom here. Gonna try to pick this plate up and go under the bottom. What should be happening is the magnet should be strong enough that it's pulling the particles from this ferrofluid and pulling it up and creating spikes, which are the magnetic fields that are pulling with the magnet, that are attracting the magnet and the nanoparticles in here. But we are not getting any type of reaction right now. So, just like our last lab, this one did not go as planned. Tried many different magnets. Could not. You look at the variables. Could it be the oil? Could it be the magnet? But what should have happened was creating these spikes, uniform spikes, due to the surfactant keeping it from clumping up. These little spikes. It should rise off the base layer of the ink and the fluid, about right here, creating these uniform spikes, aligning with the magnetic field of the magnet, which would create the ferrofluid. So my name is Alex, and this is the lab. Thanks.